Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Multi-Agent Systems. When AI bots team up to solve bigger puzzles. We've spent time learning about individual AI programs solving specific tasks. But what happens when a problem is too big for one AI? What if multiple AIs could work together? Think of it like a sports team or a busy city where everyone plays a part. Today, we'll explore multi-agent systems, where multiple AI players, or agents, collaborate to tackle bigger, more complex challenges. Imagine you have a bunch of individual AI programs, each capable of doing a specific job. A multi-agent system, MAS, is simply a collection of these individual AI bots, which we call agents, that work together to achieve a common goal or solve a complex problem. Instead of one super smart AI trying to do everything, you have several specialized AIs communicating and coordinating. It's like having a team of specialized builders instead of one person trying to construct an entire skyscraper alone. Single AI programs are great for specific, well-defined tasks, but complex real-world problems often overwhelm them. For developers, this means trying to write and maintain a single, massive program becomes incredibly difficult. MAS solves this by 1. Breaking down complexity, distributing a big problem into smaller, manageable pieces for different agents. 2. Speed and efficiency. Agents can work on different parts simultaneously, speeding up the overall process. 3. Robustness. If one agent fails, others might be able to pick up the slack or find an alternative path. 4. Specialization. Each agent can be an expert in its narrow field, leading to better overall performance. Think of a complex software project. You don't have one developer doing everything. You have a team of front-end, back-end, and database specialists. As a developer, when you think about building an MAS, you'll focus on these essential parts. 1. Agents. These are your individual AI programs. Each agent perceives its environment, takes in information, makes decisions based on its internal goals, and performs actions. They're like self-contained software modules or microservices in a larger architecture. 2. Environment. This is the world or context where your agents operate and interact. It could be a simulated game world, a physical factory floor, a digital marketplace, or even a network of computers. 3. Communication. Agents need to talk to each other. This means defining how they send and receive messages, share data, and understand each other's intentions. Think of APIs, application programming interfaces, that allow different software components to interact. 4. Coordination, cooperation. This is how agents work together. Do they negotiate? Do they follow a leader? How do they ensure their combined actions lead to the overall goal? This is where the teamwork truly happens. For a developer, getting agents to team up effectively involves designing for collaboration, defining agent roles. Each agent gets a specific job, e.g., data collector agent, analysis agent, decision maker agent. This is very similar to how you'd break down a monolithic application into distinct services or modules. Standardized communication. Establishing a common language or message format, like JSON or a custom protocol, and a robust way to send these messages, like HTTP requests, message queues, or event buses. This is crucial for agents to understand each other. Shared knowledge, goals. While each agent has its own local goals, they all work towards a larger, shared objective. You might design a shared database, a central blackboard where agents post and read information, or a common understanding of the system's state. Interaction protocols. Asterisk setting clear rules for how agents interact, who talks first, who gets priority, how conflicts are resolved. This is akin to designing the workflow and business logic between different parts of your software system. Multi-agent systems aren't just theoretical. They're solving problems every day in various domains. Smart traffic management. Asterisk imagine individual cars, agents, communicating with traffic lights, other agents, and road sensors to optimize flow, reduce congestion, and prevent accidents. Each car tries to reach its destination efficiently while coordinating with others. Supply chain optimization. Asterisk different parts of a supply chain, suppliers, manufacturers, distributors, retailers, can be modeled as agents. They communicate and coordinate to ensure products are made and delivered efficiently, responding dynamically to demand changes and disruptions. Gaming AI. Asterisk in complex video games. Groups of enemies or allies might be multi-agent systems, coordinating their attacks or defenses without a single central controller, leading to more realistic and challenging gameplay. Robotics teams. Asterisk swarms of drones or factory robots collaborating to build something, explore an area, or perform complex logistics tasks, each with its own task but working towards a common goal. As a developer, approaching MOS feels familiar because it leverages core software engineering principles. Think modular. Asterisk break down your problem into smaller, independent services, agents, with clear responsibilities. Define interfaces. Asterisk focus heavily on clear communication protocols and data exchange formats between agents. This is where your API design and system integration skills become invaluable. Start simple. Asterisk don't try to build a complex ecosystem immediately. Start with 2 or 3 agents with clear, simple interactions to understand the dynamics before scaling up. Leverage frameworks. Asterisk there are libraries and frameworks, like Mesa for agent-based modeling in Python, that can help you structure and simulate MOS, abstracting away some of the low-level details. This allows you to focus on defining agent behavior and interaction logic, helping you rapidly experiment with your AI teams. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.